Hey everyone, good morning, good afternoon, wherever you're joining us from. Thank you so much for taking time today to participate in our virtual meetup, Unlocking Agility with Warehouse Native Experimentation. I'm Sid from the marketing team at Statsig, and we're really excited for what's in store for today's webinar. We have two amazing presenters today, Craig, who's a data scientist at Statsig, and Jared, who's joining us as our special guest, who's an engineering manager at Whatnot. As people trickle in, I just want to get a few housekeeping items out of the way. Um, can we have the next slide, Craig? So we've enabled the Q&A and the chat for this webinar. So if you have questions, keep them coming on the chat throughout the session, and we'll set some time at the end to answer those live. We'll also be sharing some resources on the chat throughout the session, so take advantage of that. And we'll also be sharing some more via email along with the recording in a few days. I also want to encourage our audience to take advantage of our Slack community. We've got thousands of experimentation professionals engaging on Slack. So take advantage of that, be part of the conversation, get your questions answered, contribute, and stay tuned for more such events in the future. So let's have a quick look at the agenda today, and then I can hand it off to Craig. Today's webinar will be Craig presenting for the first 20 minutes, talking about what is warehouse native experimentation, who is it for, covering some of the basic table stakes features, benefits, and certain trade-offs that you have to consider. He'll also talk about getting the most of your of both offline and real-time data and what it takes to build an effective experimentation culture. After Craig presents his bit, we'll have Jared joining us from Whatnot. That's something we're really excited for because Whatnot has been a Statsig customer for a couple of years now. And during that time, we've seen their experimentation culture grow significantly. So it's really awesome to have Jared joining us today. Thank you so much for making time, Jared, and agreeing to participate for this session. So after Craig, we'll have a few questions for Jared, and he's going to talk about his experience in experimentation, specifically what he's doing in his current role at Whatnot, leveraging warehouse native experimentation. And after that, we'll have maybe 5 to 10 minutes set aside for taking some live questions from our audience. So please keep them coming on the chat. My colleague Morgan and I are monitoring the chat, and we'll compile these questions and try to answer them at the end. Without further ado, I'm going to hand it off to Craig. Thank you all for joining in, and enjoy the webinar.
Thanks, Sid. Hey, everybody. I'm Craig. Like he said, I'm a data scientist here at Statsig. So we'll kind of be going through the whole flow of how this works as a platform, what we've observed so far in terms of trade-offs, who it works for, et cetera. Without further ado, I'm just kind of going to jump into it. So warehouse native has become a kind of more and more common term in the last couple of years, especially with the advent of CDPs or customer data platforms, where there's a lot of tools where you can move things into one place, basically. Warehouse native applications just run on top of your existing cloud data warehouse. This is often something like Snowflake, Databricks, Redshift, BigQuery. And what these do is remove the need to egress or transfer data. Since you're running things directly on top of your own tables, you're getting basically a direct sync all the time with your applications that are using that data. This is really valuable for folks who want to maintain a single source of truth for business metrics. So the data that's feeding your dashboards, that is feeding your business metrics, your pipelines, your ML, is also feeding whatever this application is. For warehouse native experimentation, it is a subset of this. You generally will configure and run experiments through some sort of vendor console and their SDK for assignments. And then you'll run the statistical analysis for experimentation in your warehouse on your metric data using your compute. We have a little boundary chart here, but if you look below, we have this concept of you have your own data warehouse, you have your own metric event level data, and you'll have either assignment data that's coming from your in-house tool, or it's coming from a vendor SDK assignment and being ported into your warehouse through your own logging or through some other tool. And then within your warehouse, the vendor runs statistical calculations, downloads just the results, and displays them in their console for you to make decisions on and keep a ledger of your past results. Where we found warehouse native works best is organizations that have established strong data ecosystems or complex measurement problems. This is where that source of truth becomes really critical for folks, especially in cloud platforms, which are often event-driven. You'll get a decent amount of jitter between the source of truth data in your warehouse and what you have on an external platform. Warehouse native basically just eliminates this problem. Another big benefit people see is that you can make your own choices around cost complexity trade-offs on measurement. Often on cloud platforms, there's sort of like a cost baked in of whatever features they decide to provide or not. Whereas warehouse native, since you're paying for the compute and storage, you can kind of make those trade-offs yourself when they're offered by the vendor. So we'll talk about that a little more in a bit. The last two are kind of around meta-analysis and building a corpus of knowledge. So one really nice thing about warehouse native, since all of the data is living in your warehouse, you can reanalyze results, not just in the vendor console, but also using SQL. This is all just stored as tables in your data warehouse at the end of the day. And also makes it really easy to run meta-analysis. Since you have result data sets for every experiment you've ever run in your warehouse, it's really easy to do follow-up analysis, understand patterns between how metrics move in experiments, all of that good stuff. Where we've seen warehouse native be a little less attractive is when folks are mostly using engineering to drive experimentation. And this usually is because they have a focus on real-time data. So when you're running at scaled experimentation, a really big concern is making sure to avoid regressions. And that often requires really quick feedback loops from launching an experiment to seeing if it's doing badly or not. Usually this is just bugs, but it can also be that a feature is working way worse than you intended it to be. And being able to kill those quickly is really important at that scale. Secondarily, organizations that don't have centralized metrics or a warehouse definitely can struggle a bit with warehouse native. If one team's using one warehouse and another is using another platform entirely, and the data doesn't all exist in one place, it's hard to connect it all on a warehouse platform using warehouse native. So those cases can work, but require some legwork to get things going. Statsig is in the business of selling warehouse native, and the value proposition that we think is most compelling and true is that this is basically an in-house analysis tool, but on steroids. Generally, warehouse native experimentation is like having a large team working on your own in-house platform, but you get it for a fraction of the cost. And this is just an economies of scale situation. Vendors have full-time teams and dedicated bandwidth for solving all the stats problems. They'll usually already have a well-built assignment SDK that does real-time checks for sample ratio mismatch, et cetera. And then beyond that, it's a really big boon for data teams. You can automate away repetitive analysis. So data teams get to focus on helping advise on experiments, do specialized follow-up analysis, and it basically just frees up a lot of time there. The last huge benefit that I'll call out is that analysis is consistent and can be templated. So you can have controls on how people run experiments. You can enforce that everyone runs things with the same significance or has to have a justification for different ways of doing analysis. What we've seen is that in-house analysis can be really inconsistent, and that can lead to bias, right? If one team is kind of loosey-goosey with how they run experiments, they'll just ship things left and right and not really have the highest standard of what they're releasing. We have a fun 4-point spider web, so not the largest spider web here on the right, trying to kind of show this off. We have this purple square for warehouse native experimentation, and this blue diamond for what kind of most in-house experimentation platforms look like. And the thing to pay attention to here is it's worth calling out in-house experimentation tools are always going to be the most customized for your use case. You're going to be able to solve exactly the problems you need to solve. Warehouse native gets pretty close though, because of all the customization you can use. And it also gives you the tools you need to get really fast experiment velocity going, because you can just scale your program so much easier. And it also offers that consistency and repeatability and health checks and making sure things are actually working well. And what we find is generally both offer a lot of transparency. For warehouse native platforms, you generally have total access to the SQL, total access to the data, total access to the algorithms being used. In terms of the trade-offs, we've already mentioned privacy and data redundancy a little bit, but data remaining on-premise, not having to egress it, is really attractive for folks who have sensitive data or who, again, don't want to see any jitter, don't want to have to explain away gaps between their experiment results and their top line. The general downsides are you do need to maintain compute and storage. So you're the one responsible for keeping that data around on your tables. And also another important thing to call out is you, out of the box, get less real-time diagnostics and early failure trigger. And that's sort of that engineering culture I mentioned before, where if you're trying to run hundreds of experiments at once, you do want to have early signal on what's not working, especially if it's causing bugs for a large portion of your users. Tagging onto the value prop, what we found is that Warehouse Native makes it easier to offer some special features that data teams in particular really enjoy using. So one to call out is that was much more popular than we expected to be, is anonymous ID resolution. So the concept of tying together different identities into one for measurement platforms is not a new one. But the specific use case we've seen a lot here is people can run logged out user experiments, but measure logged in metrics. So tying together, say someone visits, they join your platform, they start paying, and getting that user level metric easily onto those visit ID experiments is a convenience feature, but a really powerful one. What we've also seen people really get value out of is having just SQL-based customization as part of your measurement platform. So this can be as simple as providing a SQL-based filter for a metric. So you can do some sort of complex logic on JSON fields, or you want to do some sort of array parsing. It's also really powerful in that you can, if you have like an existing semantic layer or metric definition layer, you can just sync it with these platforms. And since it's reading directly from your source of truth, your existing definitions work. Additionally, since you have your own tables, we can manage joins for you doing that. So where this usually comes up is in user dimensions. That's the most common use case. But people can provide a global table of, say, user to country or to an engagement level, which we would join on timestamp. But those we will be able, you can apply that to any query, any experiment, and get those results by those cuts for follow-up analysis. The last thing, and I alluded this to before a little bit, is cost controls and transparency. Since things are running on your warehouse, you can see both on your warehouse and on a lot of vendors in your console, the total cost, the wall time, how much data you're scanning, all of the things you need to basically show end users like, hey, there's a cost to running this, be cognizant of that. And you have tools to manage it by managing the data you're reloading, by managing the tools that you want to use in your analysis, et cetera. So with all that in mind, what does it actually look like to analyze an experiment on Warehouse Native? And the nice answer is it's pretty easy. Generally, we find once people have their data connection set up, they can get results in less than an hour. The first step is just connecting to your data. So this will usually be a user day level metric data table or event level data from some sort of real-time logging. Once you have access to that data, you just create metrics on top of them. Most vendors offer basically what is a lightweight semantic layer. It tells them how to aggregate things, what filters to apply, what kind of statistical treatments you want to do, like Windsorization, Cupid, et cetera, on this metric. And then you'll configure your experiment. So if you want to do this quickly, you're probably using an existing experiment you've already run. You can also generally configure and run an experiment through your vendor. But once you have that, you'll usually go through a flow of setting up, hey, here's the description, here's some screenshots of what the treatments do, here's the hypothesis, and here's my evaluation criteria. I've created these metrics, and these are the metrics that I think I'm going to move, that this experiment is a success if they move. And finally, you just run an analysis, and this can usually be done on demand. And what this will do is the vendor will create a query or a data pipeline that runs on your warehouse, is managed. And at the end of it, they just export the anonymized results. So these aren't like user level data. It's this group had this mean and this standard deviation. And from there, they'll calculate the confidence intervals, et cetera, that you need to make decisions. I mentioned this before, and I think it's pretty important. For most scaled experimentation platforms, we kind of think of it as there's like 3 types of analysis. So the first is the bread and butter and is kind of what you see in the last slide, and that is like hypothesis testing. And this is where you want to be really rigorous. You have a clear hypothesis based on some evaluation criteria. You expect to move some metrics based on the hypothesis you set ahead of time. You've probably done power analysis to understand what kind of movement you'll be able to see. And when you're looking at that, you're being really careful. You're trying to correct for multiple comparisons. If you see a surprising result, you're being skeptical of it. All of the things that will help you make good decisions. And so that's the primary analysis you're doing. But there's two pretty critical secondary analyses. One of them is sort of exploratory follow-up analysis. And so this is, you'll have your primary metrics, but you can also have secondary metrics. And those are more observational. You're not going to be making decisions off these. If you have 30 metrics and see one move in a static way, that's probably noise. But if you see a trend in them, it might be worth following up, doing secondary analysis, running another experiment in the future to understand, hey, like, does this treatment cause some effect we didn't expect? Or does this work better in some countries or on some kinds of users? The third, which is increasingly critical as you scale experimentation platforms, is having early real-time analysis. So this can be diagnostics. This can be like real-time, something like sequential probability ratio test where you have an early kill switch. But this is like an important part of really running experimentation programs, getting past just analyzing and getting into the running of large-scale experimentation. This can be a gap in warehouse native. I think I called that out before. And this is usually because either warehouse data is delayed, like you have a daily ETL that loads everything into your metric store, or there's a vendor warehouse barrier, right? Where either you're having to log stuff yourself as a result of the SDK, or stuff is being kept in the vendor's warehouse and is slow to come to yours. I think this is going to be an area of a lot of development in the next couple of years. This is solvable. You basically can couple real-time infra from vendor SDKs with warehouse metrics. So the idea here is you can get assignments and event-based diagnostic metrics in real time. So within an hour, you can export the assignments that the vendors log into their own warehouse or log them to your own streaming pipelines. And then you can't get a complex metric like 7-day revenue or something like that in real time, but you can get crash events. And so if you have all this written to your warehouse on demand, you can get early signal within usually an hour of what your experiment's actually doing to users and have that confidence that you're not breaking things. Again, back to that sort of triple form of analysis. The idea here is you're going to run a full hypothesis test. We recommend doing it on a specific term, so you have a fixed horizon. At some point, you make that decision. But you can also do this early checks, and you can also do these follow-up analyses as part of that flow. This last slide is very dear to our hearts here. And it's hokey, but experimentation is a team sport. Generally, you're going to be pulling in a bunch of cross-functional partners to be running an experiment. And we find that this works best with handoffs. And we've also found warehouse native can help these handoffs be really explicit and clear and nice to work with. So where we see this happening is in kind of 3 phases. One is inconsistency. What this normally means is that data teams are able to take the existing artifacts they build and maintain and have a direct linkage in the tool to them. So there, in cloud platforms, we often see this gap where engineers are logging events. They're kind of trying to recreate like a revenue metric by logging it themselves, but things are a little different. For data teams, it's a little awkward because they'll help them set up those metrics in the platform, but they don't mesh with their source of truth. Here, there's none of that gap. They can set things up directly. There's a lot of access controls. So, a data team can own a source. No one else can touch it. And you can set up like verifications to say, hey, this is a trusted source data. You can use this. We've stamped this. From that, you get a lot of inherent modularity in warehouse native. Since you have like these trusted sources, they're validated, they match what's in your warehouse. Once these are set up, the idea is kind of something we believe in really strongly. Anyone can build on top of these and create metrics, create analyses. Once you know for certain that this is the right source of revenue, you can filter that revenue, you can group it by things, you can subset it. And this is really powerful. Generally, what we see mature orgs doing is having a set of verified metrics, and those are the things that are going to be evaluation criteria. But people will create new metrics either in Explore queries or as their own set of metrics to understand what's actually happening behind the scenes in their experiments and what's driving those actual movements in the evaluation criteria. And at the end of this day, this leads to really broad visibility. And this is having an experimentation platform leads to broad visibility generally. Where warehouse native really stands out is, in addition to everyone being able to see results, having this very democratic visibility, context, discussion, anyone can see what's happening in the analyses and reproduce them to some extent. It's very clear exactly what's going on in terms of the calculations. The data is available in the warehouse if people want to do meta-analysis or understand how things actually look on the back end. It's totally open. And this basically, both within companies, lets people chat about what's going on. And it's also really, really productive in terms of the like kind of vendor relationship. Jared is actually a great example of this, where he's like read the queries happening and given me thoughts on what he might want to change. And so we've been able to sort of work together collaboratively on making the platform work better for them. That's the end of my slides, and that's, I think, a pretty good transition to Jared. So I'm going to hand it off to him and let him chat a little bit to you all about his experience, kind of his thoughts on this whole topic.
Hey, folks. Nice to meet you all.
Thank you, Craig, for sharing some great pointers, which I'm sure is super helpful for those evaluating warehouse native solutions. Really excited for the next part of this webinar. Thank you so much, Jared, for joining us today. It's great to have him share his expertise in the space of experimentation and specifically warehouse native solutions. To kick things off, Jared, for our audience who may not be familiar, can you tell us a bit about your company and then also a bit about your current role and what your team does, how experimentation fits into it?
Perfect. Yeah. My name is Jared Bauman. I lead core machine learning at Whatnot. Whatnot is the largest live stream shopping platform in the United States. For many of you that don't know, you think of this as like QVC on the internet, but with like a lot of different streams that you can tune in to people selling all different kinds of products. This is an industry that's, worth hundreds of billions of dollars in revenue overseas and kind of like East Asia. And so an exciting growth area here in the United States. My team works on quite a few things. So everything from the fundamental infrastructure required to set up ML models, actually building those ML models in production, and then everything that has to do with kind of experimentation and making sure that we're making decisions in a statistically rigorous fashion.
That's awesome. I also want to dig into a bit of your background with experimentation before Whatnot. I know you worked at DoorDash previously. Can you share any interesting learnings or insights you had from your time there? And also maybe how DoorDash's in-house solution compares to, like, say, the whole build versus buy discussion compared to buying a third-party platform. Can you just, share some insights into that?
Cool. Yeah, let me start with your kind of first question first. So how I really got into experimentation was my first job out of grad school. I actually worked at a small firm that really focused on building highly efficient, low sample experimentation tests. So think of this as tests that are actually physically costly to run and set up. So e.g., Walmart wants to test a new way of displaying end caps in a small number of stores. So actually getting that matching right and getting as much statistical power out of that test as you can is really important because it has a physical cost of actually setting up. So that was how I got started in this area. I had a couple kind of other jobs that I went through. I was at McKinsey for a while and then Lyft. And then I landed at DoorDash, where, among other things, I was the algorithms lead for our experimentation platform. Lots of really, really interesting stuff on experimentation at DoorDash just because of the nature of the marketplace. Typically, you have to change things at an entire city level in order to observe effects. And so things like cluster robust standard errors and these other kind of more advanced statistical technologies that typically you can think of as, that's something you just think about in grad school and then never use in real life, actually become really paramount. I also did some work in kind of the fraud and trust and safety space where things like conditional average treatment effects and kind of targeting and tailoring different initiatives to kind of subsamples of the total population become really important as well. So lots of experience kind of getting my hands dirty in the meat there. I can go into more on that if folks have questions. But to your second point on build versus buy, Obviously, I think we have no regrets about standing up our own experimentation platform at DoorDash. I think at that time that was the right decision, and kind of given some of the needs of that organization in particular, it was the right call at that time. That having been said, I think the industry has also really evolved over the last like 4 to 5 years, whereas solutions like Statsig simply didn't exist or were very immature 5 years ago. They are now pretty powerful and give you most of what you would want from a fully fleshed out platform. For really large companies, that added flexibility of being able to kind of like really tailor things to your own use case and ways of experimentation probably still adds value. But for much smaller firms, I think, buy makes a lot more sense these days because you can get 90% of what you want without having to, hire 4 full-time engineers to build and maintain your platform.
Oh, thanks for sharing that, Jared, because there were a few people who were, asking about how to think about, build versus buy and, having with your experience at DoorDash and now at Whatnot, where obviously you've been using Statsig for a couple of years now. It's interesting to get that perspective on capabilities. So just pivoting more into, the warehouse native aspect. Like I mentioned earlier to our audience, Whatnot was using Statsig for a couple of years now. So Jared, can you talk about what led your team to pivot to the warehouse native offering last year? Just a little bit about that thought process first.
Yeah. So I think when we were approached with kind of your value prop for warehouse native, I think a few of the things were really exciting to us. And then I can kind of get into the details of how that's actually panned out, if you all would like as well. First was like trust and transparency. So the fact that, we no longer had a black box that Statsig kind of consumed our data and spat some numbers back out at us was a big pro. That just gets people to trust the results far more when you can be like, yeah, this is the Statsig result. Oh, and by the way, here's the query. You can go check it for correctness if you are really concerned. That was kind of a really huge win to get people to really buy into the platform. Secondly, agility, I think was really big. Right now, cloud does have some limitations on like, to get Cupid set up for variance reduction, which is really, really important for experiment power. All the metrics have to be added before the experiment starts. That is not true in a warehouse native world. You can add things on the fly. And so if you mess something up in setup, there aren't real consequences, which I think was really, really nice. Third was, I think it does have more flexibility than cloud in a variety of ways. First, you can customize the Cupid window that you use to look back. We changed ours from, I think, the default of 7 to 14 days and got some meaningful variance reduction on our most important metrics as a result of that change, along with things like Windsorization rates. Again, we changed from the default because we have a little bit more of a skewed business than typically average, and therefore less Windsorization proved to be more advantageous to us. Finally, the other thing that was really, really interesting to us was basically the efficiency. So you can kind of think of like, there are some metrics that, one, they're absolutely massive because they're things like user engagement metrics. Did they click this button? That generate a huge amount of data, but you typically only look at them in like 1% of experiments. With a cloud-based application, you have to take that data and send it over the wire. And that's very costly, both from our perspective and from Stat6's perspective. Like it adds cost for all parties involved. That ultimately gets reflected in your contract. But with Warehouse Native, we can now have all the data just sitting on our own platform, and it only gets access when we need it for an experiment. So that's a huge efficiency gain there. More so, it enables us to like stop aggregating things at a daily basis to send over, and enables us to do analysis on the raw data, which for a variety of reasons can add a lot of value. You can start adding metric dimensions to enable you to do like slicing and dicing on the fly in a way that would have been cost prohibitive if we still had to send that data over the wire. So overall, like those four things were kind of all really, really appealing to us. And like, I think the transition has been a really positive experience because I think we've seen everything that we'd hoped for actually materialize.
Nice. Thanks for sharing that. I think a lot of areas of value proposition around efficiency, trust, agility, and flexibility. And it's also helpful for our audience to know what those considerations and trade-offs were when you moved from a fully hosted cloud-based solution. I guess we've been having a few questions coming in on the chat that I want to get to, a couple of those. But Jared, any final you did touch upon things like build versus buy,
Yep.
but do you have any final thoughts or advice for someone who is starting their journey of experimentation and looking into warehouse native solutions? Any anecdote or tip that could help them successfully implement a solution?
I don't know if I have tips for implementation, but I would kind of just reiterate what we talked about on the build versus buy front. I think the equation has fundamentally changed over the space of the last 5 years. And whereas I think the default was to kind of spin your own 5 years ago, I would recommend that anyone who still thinks that's the right way to kind of look at the economics of that decision again. I think Statsig and other platforms have fundamentally reached an inflection point where the economics of building your own versus buying looks fundamentally different unless you have an extremely specific use case that kind of these broadly based platforms wouldn't support out of the box.
Nice. Thanks, Jared. I want to take a question now from Carlos and Craig. Maybe you can also chime in. Can direct it to both of you and get your thoughts on this. So Carlos's question for everyone is, would you recommend exporting the experiment data from the vendor software once the experiment is over? That should allow you to get the benefits of the data warehouse and the real-time control of experiments. Any reason this wouldn't work?
Got it. Yeah, that's an interesting question. So generally, like on cloud and warehouse native, we support exports for summaries and for the raw inputs to the statistical analysis. Sorry, and people do use this for the meta-analysis. So in that sense, it's a convenience feature. In terms of the having stuff in your warehouse and being able to analyze all the intermediary steps and understand what's happening, that it won't solve. So yeah, I guess it's a convenience feature for meta-analysis. It's not really possible in an export world to get the full stack of understanding what's happening.
Yeah, the other thing I would add is it depends how tightly you are integrated with like Statsig or another vendor for this real-time processing. So for example, on our end, we were only sending nightly batch jobs at the 24-hour mark. So we actually didn't get any of the real-time benefits that in theory you could be for cloud. So for someone like us, that wasn't even kind of a real drawback.
Another question from Dom and Jared. This one is directed to you. Did you see your warehouse compute costs or consumption increase when you flip to warehouse native? Is that something you can touch upon?
Yeah, I mean it will increase as a result of the fact that this is being run on your warehouse versus being thrown over the wire. Right now, we're still kind of in the process of transitioning. Almost all of our analysis is done on warehouse native now, but we still have cloud spun up for a few legacy reasons that we hope to soon sunset. So I can't give you kind of a super clean answer there, but I would expect that it's possible that your database costs would go up, but I think that should be more than offset by savings elsewhere. I think it's much cheaper for the Statsig folks, and that's probably going to be somewhat reflected in your contract cost.
Craig, anything you'd like to add there regarding just the total cost of ownership or just between say cloud warehouse native? Any advice?
Yeah, generally what we've found is that people are able to run things more cheaply on their side because of a couple of factors. One is that in cloud, for us to have data available for folks, you pretty much have to run everything every day. Whereas for warehouse native, what we'll see people do is sort of retire an experiment after the first couple of weeks, and then maybe they'll catch it up later. So there's not as much to load. And secondarily, people have like more control. So we have options like turbo mode where you can basically like spot analyze things instead of calculating all the time series, and that'll reduce cost. So that helps a lot. I'm curious as well to hear what Jared and team find in terms of their costs. We've seen people running like 500K to million user experiments for pretty much, I think, like a couple hundred analyses for less than $15. So it's definitely an open area, and I think like with some of the scaled companies, we're still trying to see if there is a limit we'll hit. But generally, costs have been less of a concern than people have expected when they're evaluating.
Yeah, I would say like it could be that our costs come down. What makes it harder for me to give a straight answer here is like simultaneously we're beginning to take advantage of some of the things that warehouse native unlocks. And so, for example, like doing bigger computes on our end because we would never have sent that data over the wire before. But I wouldn't be surprised if we were kind of break even on the cost side and like definitely lower total cost of ownership.
Nice. One more question is, I think it's more of a statement, and they want to have their understanding validated. And so this question says, warehouse native analysis can be more ad hoc, not requiring metrics and segments to be set up in advance for an experiment. Is that an accurate statement? Do you want to take that, Craig?
Sure. I think Jared also alluded to this as well. Yeah, you have pretty much total control over what you want to load. So if you want to go back and add a metric to an experiment, we like directly support that. There's you can add a metric to a historical analysis. You can rerun an entire analysis from a year ago. Again, like it's basically your choice. You know, you'll incur some costs, but you can run it if you want. So that's a ton of flexibility for folks.
I think we've probably hit on all the questions that have come on the chat, and we've also tried to like answer some of them as a DM. To our audience, I just want to reiterate that we will be sending you the recording of today's session. We'll also send you some resources, so that'll help you, just tighten your grasp on these concepts and also evangelize it internally within your organization. I guess the one final question, and just want to make sure I'm understanding this correct, and it's from Jack. Jack asks, is the warehouse native feature that you split the warehouse engine for different experiments? Do we want to just clarify that?
I would probably need to understand a little better the exact motivation here, but generally everything's being run through SQL, and that's a pretty common interface. Like there's obviously dialectal differences, but in terms of like using it with Snowflake, I imagine that this would be pretty invisible from the engine side. So yeah, you could change it. Right now we don't really have a concept of flipping it for different experiments. I think that comes down to that like scale exploration of if we need that to handle different scales, we'll do it.
Nice. I guess that touches upon like all the questions that were asked. Thank you so much, everyone, for tuning in today. Just a final reminder that you can join our Slack community, follow us on LinkedIn. We have lots of updates, product updates, event updates, and just a lot of great resources that you can take advantage of and engage with the experimentation community. If you have more product-specific questions, you can reach out to our sales manager. That's Sammy@statsig.com for more information. We will send you the recording of this webinar in a few days. But I want to thank Jared for joining us this morning, taking time off your busy schedule and joining us to share your experience in the domain and also with Statsig and Warehouse Native. And of course, Craig for explaining all these concepts at the beginning. Craig also has been working with tons of customers like Jared. So a lot of what was shared today is based on our real world knowledge partnering with customers. So we will stick around maybe for a minute. But if there are no more pending questions, thank you so much for joining us, and bye for now.
Thanks, everybody.